Alright, welcome to the first video on some of the algebra you guys need to know for the class. This is my first time making a video with this software, so hopefully it goes well. So what I want to talk about first is how to solve quadratic equations. Now hopefully most of you remember the quadratic formula. If not, it's something I can provide for you. But that's x equals negative b plus or minus the square root of b squared minus 4ac. Get that square root over all of that stuff. All over 2a. So we need to pick a sample quadratic equation to work through this with, and the one that I have prepared is 2x squared plus 6x minus 3 equals negative 2x plus 4. Now, kind of the first step in any one of these quadratic equation problems is recognizing that you have a quadratic equation. And when you have some terms that are just numbers, and you have some terms that have just a regular old x in them, and you have some terms that have an x squared in them, that's when you're going to need to use a quadratic equation. So we have just number terms, we have terms with x, and we have terms with x squared. So let's get those out of there. So the first thing we're going to want to do in any quadratic equation is get everything on the same side of the equation. So to do this, it's just some simple algebra that should be well within all of your reach right now. So we've already got 3 of these things on the left side and only 2 on the right, so I'm going to move everything over to the left. So that 2x squared can stay here, and then we have the 6x, and then we have the minus 3. So if we want to move the negative 2x over, we're going to have to add 2x to both sides. If we want to move that 4 over, we're going to have to subtract 4. And then that leaves us equals 0 on the other side. Now we just need to combine like terms. This right here is the only x squared term, so that one just stays the same. And then we've got a plus 6x and a plus 2x, which leads itself to a plus 8x. And then we have a minus 3 and a minus 4, which gives us a minus 7 equals 0. And the next thing we're going to want to do is determine our values for a, b, and c in our quadratic equation. A is going to be whatever's in front of the x squared. So right here is in front of our x squared. That tells us our a here is 2. B is whatever's in front of the x. So that here is 8. So b is going to be 8. And c is just the number by itself, including that negative sign. So if there are any minuses in this equation, make sure you include that in your values for a, b, and c. So here c is negative 7. And again, very important to put everything on the same side of the equation first. So if the equation doesn't equal 0, then you still have some work to do before you can actually start using your quadratic equation. So now the next thing we're going to do is plug into the quadratic equation. Hopefully you guys can see that green. So let's just start figuring this out. So x equals negative b. So our b is 8, so that is negative 8 plus or minus the square root. I'll fill that in as we go. So first is b squared. So 8 squared minus 4 AC, so A is 2, so 4 times 2, times C, and C is negative 7, so we're going to put this negative in here as well. Close that square root. The whole thing is the fraction bar over 2A, and A is 2, so over 2 times 2. So at this point, if you're good with your calculator, you can just plug it right in, but I'm going to show a couple more steps. So we've got negative 8 plus or minus the square root. 8 squared is 64. Minus 4 times 2 is 8. And then 8 times 7 is 56. But we've got that negative in there, so that's minus negative 56. And hopefully you remember that minus a negative is the same thing as plus positive. I tried to do that in a slightly different color so you guys can see that. All over 2A, and A is just 2, so 2A is 4. And then we have this part under here called the discriminant, where we've got 64 plus 56, which, doing some quick math in my head, is 120, and it's positive 120, which is good. If your discriminant comes out to be negative, you're not going to have any real solutions. We won't deal with imaginary numbers in this class, so if you're getting a negative number down here, it either means what you're trying to solve for is impossible, or more likely you made a mistake in your math and you should go back and double check that. Usually remembering these negatives up here is the mistake that people will make. So let me get back to the black marker here. So we have negative 8 plus or minus the square root of 120, all divided by 4. So now we can start thinking about that plus or minus. So that means we have two options here. Our first option, so let me just clearly draw a line there, negative 8 plus the square root of 120 over 4, or negative 8 minus the square root of 120, sorry, running out of room there a little bit, over 4. So now we can just get out our calculators, and because we've got things added and subtracted in the numerator here, when you plug this into your calculator, you're going to want to put parentheses around the top. So we've got negative 8 plus the square root of 120. Take all that and divide it by 4. And we get x equals positive 0.74, so 0.74, rounding to the 100th place. And then for our other one over here, we do the same thing. We take negative 8 minus 100 square root of 120, then divide that by 4, and we're getting negative 4.74. So these are our two answers, and if we were showing work, we would want to box our answers here. In a real physics problem, only one of these answers would probably be what you need. Which one depends on what you're solving for. If we were solving for x, which was a time, so that would actually be t, then we would probably want the positive 0.74 because we don't really usually deal with negative times. But which one you pick will depend on the specific problem that you're doing, but this video is just about the process. And this is how you solve any quadratic equation problem that you will encounter. So with that, I'm going to clear this out so that we can start the next one. Another thing you guys will need to do is solve a system of equations. And a system of equation means you have multiple equations with multiple unknown variables. So you might have x and y that you don't know. As a general rule, if the number of equations you have is equal to the number of unknowns you have, so unknown variables, basically like x, y, any variable you don't know the value for, then you're good to go. So the one we're going to work with today is these two equations. 7x minus 4y equals negative 7. And the other equation is going to be 10x plus 2y equals 44. So now we get to our first step. So we can see here that our number of equations we have is 2, and our number of unknowns we have is 2, x and y, x and y. They appear in both equations, but it's still just x and y. So that means we have enough information here to solve this problem. The first step is to solve one of the equations for one of your unknowns. And it can be either equation, usually better to pick the simpler of the two. For reasons that actually don't really matter, I'm going to choose this second equation to start with. So I'm going to take this 10x plus 2y equals 44, and I'm going to solve it for one of my unknowns. So I want to write it so it either looks like this: y equals with all of the rest of the stuff on the other side, or x equals with all of the rest of the stuff on the other side. So I'm going to solve this one for y. So first I'm going to move that 10x to the other side. So that equals 44 minus 10x. But right now this equals 2y, so I'm going to divide both sides by 2 to get y equals 22 minus 5x. So now we can get on to the next stage in our solution. We want to plug this equation our other equation. Oops. So before we used this one over here, the 10x plus 2y equals 44. So since that's the one we used to solve for y, we need to plug into y into the other equation, the 7x minus 4y equals negative 7. So we have 7x minus 4, and now instead of y, we know y equals 22 minus 5x. So we can just put 22 minus 5x in place of y. Note that the parentheses here are very important. And then that equals negative 7. And now we can kind of rearrange and start to group like terms. So I'm just going to go back to black here. So let's factor this out, or rather distribute. So when you have a number outside of parentheses like this, that number goes into both terms inside of there. So we have minus 4 times 22, or negative 88. And then we have minus 4 times negative 5x. Both this negative out here in front of the 4 and this negative in front of the 5, you have to think about both of those. So negative 4 times negative 5x is plus 20x equals negative 7. So now this is just a regular old algebraic equation, so we can just rearrange and solve for x. We've got 27x on the left side, and if we want to get rid of this negative 88 on the left side, we need to add 88 to both sides, and we end up with positive 81 on the right. And if we divide by 27, we get x equals 3. So there's half of our solution. Now we need, pick a new color here, orange, sure. We need to take our value for x, and we need to plug back in to find our other unknown. So we can plug back in anywhere. We could plug back into either one of our original equations, or we have an equation that just solves for y right here. Any of those three equations circled in orange, you could plug the value of x equals 3 into there and solve for y. I'm going to use this one just because it's already in a convenient y equals form for us, so we won't have to do much extra work. So y equals 22 minus 5x, and our x is 3. So that's 22 minus 5 times 3. So y equals 22 minus 15, or actually, let me go back to black here. 22 minus 15 is 7, and that is our other answer. So this is a pretty simple, straightforward example, just with two simple equations, two unknowns, and both of the answers were integers, you'll notice. I picked this problem specifically because I didn't want to have to deal with decimals and rounding. But we'll see things like this a lot over the course of the term. If you ever feel like you don't quite have enough variables to solve using just one equation, try setting up a system of equations. So keep track of all of the different equations you have and how many total unknowns you have, and just keep compiling new equations until the number of equations is equal to the number of unknowns. Once you get to that point, then you can just solve a system of equations. Even with more than two equations, it's still the same process. You're solving one equation for one of your unknowns and plugging it into another one, and then you just continue that process until you've solved for all of them. So that should be just about everything for today. I'm not sure what's going on about copyright stuff, so I'm just going to go ahead and throw on a copyright 2017 for me, just so Pearson can't take this and claim that they made it or anything. So hopefully this helped. I will be continuing to post more of these. I've got another video coming out that should be on Blackboard now for converting units, and another one that kind of refreshes you on how to do some of the trigonometry we do in the class. Later on, there will be worked examples posted this way. That way we can continue to focus on concepts in class, and then I can kind of talk you through big worked examples by means of these videos. And using those, you guys can view them on your own and stop and pause and go back and listen to whatever explanation you need to, so that you don't have to worry about frantically scribbling down notes and missing half of the things that I say in lecture. So that should be everything for this first video on algebra. The other things we need to know with algebra we'll kind of cover as we go, but this should be most of the kind of slightly more complicated stuff that we will do. All right, that's it.